Here we are, question 10 on chapter 13, integration. Cyclist travels down a straight road. Distance in meter for the cyclist from a fixed point after t seconds is modelled by the function of t being equal to, it's modelled by the function of f dash to t is equal to 5 plus 2t. Okay, and they tell us that when t is 0, f of t is also 0. All right, find an expression for f of t. So to find f of t, we are going to do the integral of it. So f of t is equal to the integral of 5 plus 2t. And so that integral, 5, add a power to it, 1, divide by 1, plus 2t squared, divide by the whole power. So we end up with 5x plus t squared plus c. Now, at that point, that's f of t, and we've just been told it is 0. And that will equal 5 times 0 plus 0 squared plus c, making, and I've just seen a mistake in my working there by the fact that I have done this with x's instead of t's, but I did it on that one. Okay, so c equals 0, meaning our equation for f of t is equal to, what did we have it as, 5t plus t squared. Alright, part A done. Right then, part B. Calculate the time taken for the cyclist to travel 100 meters. Okay, so to travel 100 meters, we have 100 is equal to 5t plus t squared, meaning that 0 is equal to, let's just write this out, t squared plus 5t minus 100. Is there anything that multiplies 400 nicely to give us 5 10 tens, 2 20s, 5 20s? Nothing particularly. I think what we're going to do on the calculator has a polynomial solver, so let's put it into the polynomial solver on the calculator. And we have, what's that? That's 1, 5, and minus 100. And we end up with x equals, I think we'll go decimals on this, 7.807, and also we end up with minus, sorry, not t equals minus 12.8077. Okay, that should be a t. Keep on making that mistake. Okay, so disregard, because we can't have minus time. So 7.80 seconds. Did they want it to? No, just like that. Okay. Okay, so seconds. Question 11. Let's have a little look. Right then, diagram shows the curve with the equation y equals 5 plus 2x minus x squared. Okay, and the line of y equals 2. And the curve and the line intersect at points A and B. Find the coordinates of A and B. So what we're doing is we're looking at when this is equal to 2 is equal to 5 plus 2x minus x squared, meaning that 0 is equal to 3, 5 take away 2, plus 2x minus x squared. So into the polynomial solver, I'm just going to swap all the signs around on this to give us x squared minus 2x minus 3. Don't really need to do it, but I like to. Into the calculator again, still got to open from the previous question. Okay, and it's 1 minus 2 and minus 3 in there, and we get a nice x equals 3 and an x equals minus 1, which is correct for looking at the picture that they drew. And so because they asked for coordinates of A and coordinates of B, I think I've actually got these the wrong way round. Yes, I do. They've labelled up A as the minus number, so I'll put it in as the minus number. Minus 1, 2. How do I know it's 2? Because the other line is y equals 2. It's got to be 2. And this one would be 3, 2. Okay. The shaded region R is bound by the curve and the line. Find R. Okay. First things first. Let's find the integral between the x bounds on this of 3 and minus 1 of the original equation, which was 5 plus 2x minus x squared dx, and we are then going to take away the integral between 3 and minus 1 of y equals 2 dx. So what does that all look like to us? With these, you do actually have a function on the calculator that you can just type that in and do it. They're not going to let you do that in the exam, okay? But it is worth knowing so that you can double check your answers. So let's quickly integrate this, and we get 5x, okay, raise the power by 1 divided by 1, then 2x squared divided by 2, so that becomes x squared because the 2 and the 2 cancel down, and this becomes minus x to the 3 divided by 3, okay, between 3 and minus 1, minus 2 becomes 2x of 3 and minus 1. Right then, put in some numbers then. 3 times 5 is 15, so 15 plus 9 minus 27, 3 times 3, divided by 3 is 9, okay, and that's going to be taken away, minus 1 to that, so that's minus 5 plus 1, minus makes a plus, minus 1, but it's minus, so it's plus a third, alright, and we are going to be taking away 2x is 6, minus 2, minus 2, which, needless to say, is going to become a plus 2, okay, and then it's all going to get minus, so we end up with that 6 being an 8, and it still comes out as a minus 8, okay. Think about it here. If we go from 3 to minus 1 on the graph, we've travelled a distance of 4. It's too high. 4 times 2 is 8. We've got a square of 8 that we need to take away from there, or a rectangle even. Okay, what does this orange side give us for the bit underneath the curve? Hopefully something bigger than that. So those 9s are gone, so we've got 15. What's that? Minus 5 plus 1. So ones like this, definitely worthwhile putting into the calculator to stop silly mistakes happening. Okay, plus 1 over 3. Alright, minus 11 over 3, which is like minus 3 and 2/3, and it's a minus, so it's plus 3 and 2/3. And when you take away the 8 on that, we end up with 32 over 3. which is 10 and 2/3. Okay. Was that all for that one? Yes. Okay then, onward bound with question 13. No, question 12. Trying to sneak away on me. Alright, find the integral of, what's that say? X to the half minus 4, x to the minus a half, minus 1, dx. Looks a bit intimidating, but all we have to do is multiply it out. Okay, so multiply it out to get ourselves, in essence, a quadratic, if that makes sense. So what happens when you do it? You add the powers together. So a half take a half gives me x to the 0, okay, which will become 1, and then I get minus x to the half, that's the x to the half times minus 1, and then I get minus 4x to the minus a half, and I get minus 4 and minus 1 gives me plus 4, okay, plus c, and so remembering this is 1, okay, I end up with, yeah, we'll put the 5 in front of it, will we? 5 minus x to the half minus 4x to the minus a half plus c. Okay. And now they want us to do the integral of all of that between the limits of 4 and 1. So I'm just going to take this answer that we had to part A. We can drop the plus c, and we're working between 4 and 1. That's correct. Well, that would have been all very wrong because it's not that at all, is it? Once we have done that, we should probably get rid of that. We'll keep that one. We should probably actually do the integration, not just the multiplying out. So all of that still needs to be integrated. All of that still needs to be integrated. So this becomes, and we'll do it, this becomes the 5x. Okay, so when we add 1 onto that, it becomes 3 over 2, x to the 3 over 2. And if you're dividing by 3 over 2, you're multiplying by 2 over 3. Minus 4 times, now when you add 1 onto this, you become a half. Okay, so x to a positive half, and we are then multiplying by 2 over 1. So that's 2 over 1 plus c. So we end up with 5x minus 2 over 3 x to the 3 over 2 minus 8x to the half plus c. Okay, and that's a better answer to that answer. Now then, we are now going to do that for the integral between 4 and 1. Okay, so 5x minus 2 over 3x 3 to the 2 minus 8x to the minus half 4, 1. So 5 times 4, 20 minus, what's that going to be? It's going to be 4 to the power 3, 4 to the power 3, and the square root of 64 is 8. 8 times 2/3 is 16 thirds, minus square root of 4 is 2. 2 times 8, 16. Okay, and then all of that is going to be taken away from 1 times 5 is 5, minus 1111 minus 2/3. Square root of 1 is 1, minus 8. So 5 minus 2/3 minus 8 gives us minus 11. So it becomes plus 11 over 3. 20, take away 16 thirds, take away 16 is minus 4 over 3. Plus 11 over 3. 7 thirds. Alright. 10, 11, 12. That'll do for that video. See you on the next one.